And good evening. How are we doing tonight? It is Wednesday night, hump day. And folks, we are already labbing. I mean, we're just already going to town here. Doing some multicast, ipv6 multicast. But anyway, hope you're having a good Wednesday night. Tonight, we're working on trying to get through this section. ipv6 has gone surprisingly well in terms of the workbook, the INE workbook that I'm working on now. So yesterday, you may remember I was working on a not PIM SSM, but I was actually working on embedded RP, ipv6 embedded RP, which is a concept unique to ipv6, not ipv4. So I had to go learn about it, which I did. And I actually did this lab this morning before work, and I got the embedded RP to work. Also, through the process of learning, I created a lot of flashcards. A lot more. I'm not sure how many I have now, but I created a good number of flashcards, and I reviewed a lot of flashcards. I actually have been slack on the flashcards the last 2 or 3 days, so I had some catching up to do. Hey, good evening, Mark Meal. We got Mark Meal in the house, Casadix. Hello, everyone. Hope everyone's day has gone great. It has, man. It has gone well. Hey, Lantern, good evening. Yep, good evening, everyone. Glad to see y'all here hanging out in the stream. Yeah, it has gone well. Tomorrow is our Scrum team sprint review, so got a lot of stuff done today. We always end up scrambling a little bit to meet our deadlines. If you're not familiar with Scrum methodology, it has you have sprints. And our sprints run 1 week in duration, which is pretty typical. And at the end of the sprint, you do a sprint review, which is a presentation to all the stakeholders, people who are consuming your services, right? And you present everything that the team has accomplished during the sprint, and you kind of go into what you plan to do next sprint. So typically the day before the sprint review, you're trying to get stuff done. So it's a bit of a scramble today, but we got a lot of good stuff done, and still learning cool things about Azure DevOps, the pipelines, and a lot of things that you can do through there. And I think, until now, I've been doing a lot of things with Azure DevOps pipelines they have a graphical interface, right? They have a web page. But we're getting to the point where we're trying to get more efficient, and you can actually just import a YAML file. You can build your pipeline, your release, your build, any other tasks that you want to put in there, where to reference the source code for what you're going to deploy. You can actually put all that in a YAML file and upload the YAML, and boom, it creates your pipeline for you. So we're going to be experimenting with that some more. Cool stuff. Anyway, back to multicast, the pure networking protocol world. I have to say, I've been a little disappointed, and that's okay. I've always, said set yourself up for disappointment in your materials and in Cisco docs. And today, in preparation for this lab, I tried to find information, official information, on Cisco's website about embedded RP, and about ipv6 PIM source-specific multicast, which is the next lab I'm about to take on. And it's a shame because I can do specific searches. Like I'll go to, let's do this in Safari. So I'll go to google.com, right? And Safari just does this when you first launch it. And I'll do a site-specific search on Cisco.com. Like, here we go, right? Someone had never heard of PEBCAC today, which I thought was hilarious. You get configuring MLD, right? So ipv6 PIM source-specific multicast, as anyone knows, most of those who have gone through this already, you need to use MLD, which is ipv6's adopted brother of IGMP, right? You needed to use MLD version 2. So I just tried to find a configuration example. That's all I was looking for. I looked the normal route because I try to go through the menus at first, always, so that if perchance I need to reference this during the actual lab, I'll hopefully remember like the path to get to the document, because you can't search. Didn't work. So then I did a site-specific search, cisco.com, and there's nothing. I mean, you know, I went through and for example, this is, first of all, this is not iOS. So this is NXOS, right? And nothing there. But yeah, I clicked through a number of these and I was just getting nowhere. So anyway, if you need an example, I think in a lot of these cases, you have to just look at the command reference, which gives no background, usually. Or you look at the lab answer key, and it's going to tell you how to configure it. And then you try to Google that on Cisco's site and see if, you know, right, and see if there's an actual decent document. I don't know why that is. I mean, maybe, does that mean just no one is using this? I don't know, but it's on the exam. That's all I care about at this point. Anyway, enough of that. We're going to get to, before we hop into this SSM lab, I'm just trying to do a couple PCAPs. This morning, I did the embedded RP lab and got it working on router 4. I could not get it working necessarily from router 6, or router 1, I should say. And I don't know why. I followed to the letter, the commands. I don't know, it just kind of gives me, again, gives me the feeling when I'm like in this little corner of certification area that no one wants to really elaborate on or give you guidance on, but you have to know it. So like the labs aren't working exactly right and the documentation is sparse. You find a lot of things that come in exams that people either do not use at all in the real world or are special use cases. Yes, indeed, which is fine. I mean, I understand that we're supposed to be experts, but give me some dang documentation on the features. You know, someone coded them and put them into iOS. So someone wrote the code, just like they've done a lot of the other features. Hey, Cisco, come on, give me some documentation, you know. Even an example of how you would use it. I could not find one single example of source-specific multicast with MLD version 2. Lol, love your Twitter post showing broken Cisco references. I know, I sound like a broken record. I'm not, and I don't feel entitled. Trust me. I know going in that this is a hard journey. Like, no one is going to hand it to me on a silver platter. I don't expect that. You know, and I'm going to call out where I think there are huge discrepancies or deficiencies in the documentation, which there are many. And, you know, probably no one listens, but that's okay. I feel better when I tweet about it. So anyway, yeah, I did this lab. We've already hooked it up. I'll show you. This is really cool. Like, I figured this out, how to decipher this embedded RP multicast address. It is simple. They want you to know about, for an exam, they should provide the material. It does. It does. Very true, Mark Milo. So this is an embedded RP address. And this is, as an MLD host, the address that I'm going to join, which I've done here on router 3, right? So I've got ipv6 MLD join group, and here's the group. All is good in the world, and I figured out how to interpret. So this is a multicast address inside of a multicast address. Is what's happening. They're compressing the address, so they're putting the RP address inside of the multicast address, right? They're embedding it in there. That's why it's called embedded RP. So you don't have to do any configuration of rendezvous points. It's going to work automatically unless you turn the embedded RP feature off, which you can. I think. I couldn't actually find a way to do that, but supposedly you can. The way they embed this is your signal, FF7, that you're looking at an embedded RP multicast address. Okay, I figured out these next bits. Network Lessons had really good lesson on this, but I made a flashcard. I even reviewed the flashcard once, and I think I can look at one of these now and pretty much figure out what the rendezvous point address is going to be. So we have FF7, that's your signal that this is embedded RP. 6 is the scope. Oh, sorry, the next bit or hexadecimal digit is the last, represent the last 6 bits of the RP's host address. So in this case, it is the number 6. 06, this is the scope. It could be like 01, link local, right? 08, I think, is global unicast, would be the scope, global multicast. 40 is a prefix mask. If you convert this to hex, it is 64, right? So it's a 64-bit prefix. The next 2 hextets are represent the RP's prefix. So now we have the RP is prefix, the mask, which is a /64, and the last 6 bits of his host address. So that means it's going to be, for example, 2001 CC1E :/64. That is the embedded, that is the rendezvous point's IP address. And the 8 is a group, multicast group address, so we could have multiple groups using that RP. Like 1 through many. So this could be, right, in this case it's F, it could be 1, it could be FFFFFFFF, right? So that's how that works. So this indicates, I think this is already pre-configured, it may not be. It looks like it is not. So we need to add this IP to, no, yeah, it's not there. Let's add it to loopback 0. And this is going to be ipv6 address 2001 CC1E 664. We have to actually have the RP, has to have that address, right? Oh, yeah, that's right. I knew that. Interface GI0 or L0 ipv6 PIM. All right, so if we go here to router 1, show ipv6 PIM tunnel, we see an embedded RP tunnel. I think the command to see all the information you need is, no, it's ipv6 PIM. There's another command to show me what I need. I don't remember. I found it in the lesson. But let's just see now if we can ping this group address now. And we cannot, not yet. Let's see if it works on router 1. Ping FF76 0640 2001 CC1E. Outgoing interface loop back 0. Okay, that works. Show ipv6 mroute. So notice here we've got our star comma G group and our S comma G. And our star comma G has a rendezvous point, which is correct, 2001 CC1E6. Sparse, connected. Incoming interface is from router 6, right? RPF neighbor is the link local address of router 6, and the outgoing interface is GI0113. This all looks right. Where I could not ever get this to work is actually on router 6. We'll do loop back 0. Yeah, it only works from like the connected router. And I swear I've configured everything the way it's supposed to be. This must just be a... Okay, it works from there. Why does it not work from the loopback? Okay, that's cool. That was not working earlier today. Why does it not work from the source interface as the loopback? Maybe that's the problem all along. Gigabit Ethernet 01146. Wow, why is that? I think my problem earlier this morning is I didn't have my RPF checks were failing because I didn't have a routing protocol running. Because the lab said, again, sloppy labs. We're in the sloppy corner. You know how you have a restaurant, it looks really nice. There might be like one corner that's kind of sloppy. That's where we're at in the workbook right now. We're in the sloppy corner. Because it said that I needed a particular... the initial configurations that I needed. But the workbook answer key assumes that you have OSPF routing enabled, but yet the initial configs I was given to start the lab did not have OSPF, ipv6 OSPF enabled. So our RPF checks were failing. Hashtag sloppy labs. Anyway, I figured that out. I got that working. It was good in a way, I guess. It gave me a little troubleshooting practice. But I'm curious why loopbacks don't work. Let me look at the workbook answer, which I've already done today once. But again, I wanted to do this lab again because router 6 should be able to ping, and he was able to. Yeah, nowhere in this lab does it tell you need to configure OSPF, except on router 6, which is on the loopback, which is fine. Also, this is a little different because it says, the workbook answer says that you have to use a /128. But this says that the RP prefix is a /64. So that's also a discrepancy. Hashtag sloppy workbook. Interface L0. Address. Let's change it and just see if that changes if the loopbacks can now ping. Show ipv6 interface L0. See, it says 64. Interface L0, no ipv6 address. So does that change anything? Ping. No, that's still broken, and I wonder if the other ping is now broken because we're using an incorrect mask, or does it even matter? It doesn't. Okay, that's fine. At least we know that. All right, I'm about done with this lab here. This is either an image issue or just a poorly written lab. I don't workbook lab. I don't know, but we've got some packet captures. That's one consolation. We can see our pings. I'm interested in seeing if there's a PIM register. I did not see one earlier, like the first packet sent. Where's our first ping? It was well below here. Yeah, we need an echo. Where's our first echo? Oh, let's do filter on the destination here. Ooh, we do have a register. Okay, I did not get this before. This is nice. I wanted this. So notice this goes over the PIM tunnel. It gets encapsulated in the PIM tunnel. Yeah, that's what we want. Okay, that's cool. So from this, I want to, our little specimens here. Why is that red? And this one is not. Oh, payload length is 0. Either this is a lack of recognition of a packet in Wireshark, which we're dealing with like corner case protocols here, so I wouldn't doubt it. Or it's just some sort of error in transmission. Now, both of these have it. All of these have it. The only one that did not is the initial one. Go figure. 106 bytes. Yeah, these are all empty registers. Strange. Okay, then we have the echo request. Let's look at MLD. Well, we won't have any MLD packets here. I think I've already captured some of those. If not, we'll turn that on as well. Okay, BGP. Yeah, we have not. We've been lax here. All right, so let's do ipv6. Let's do an MLD capture. And that would be advertised from router 3. Makes me wonder though. I'm pretty sure I'm like missing some. Yeah, I know. You can go away. Goodbye. I'm missing some packet captures. I swear I'm missing packet captures. Is this folder going to where I think it's going? It is. Okay. All right, so let's save this. Whoa, what is going on here? Okay. Oh, here we have, okay, so it did, oh, you know what? I bet it killed my other one. Uh, Okay, multicast listener report. Multicast listener query. Let's snag that one. That's good enough. All right, file. Export specified packets. And this will be marked packets. ipv6, PIM. Okay, we got what we wanted there. Spammy windows, gonna get rid of those. All right, all set. Range list, that's what the command I was looking for. Show ipv6 PIM range list. Okay, I need to add that command to a flashcard. And we've got coffee tonight, folks. Needed it tonight. Hope folks are ready for Valentine's. I will be streaming tomorrow, most likely, because we're actually postponing Valentine's. Going to be like on the weekend due to some scheduling things going on. But so yeah, I'll be streaming tomorrow. All right, so how to create a flashcard. You basically are taking notes in the form of a question to trigger your memory, right? So which command will display any ipv6 embedded RP groups? Show ipv6 PIM range list. There you have it. We just took a note. Simple. All right, so this is good. Got this info. It is time to shut down the lab. This lab. And go on to the next one. ipv6 source specific multicast. And for this one, we want to configure router 3 again. R3 will join FF368 on VLAN 37. Only accepts sourced from R6 E146 interface. All right, same pretty much. And we want ipv6 initial multicast, which is this one. I have my suspicions, though, about this. Let's look at the startup configs, see if they match what they're supposed to be, because this has been really... either I did not paste correctly, or... these were copied wrong or something, because it has been... see, these are in OSPF. Is this one? It's not. How did that happen? All right, that's been what's kind of plaguing me here. Save. Let's hit it like 3 times for good measure. Save, Eve. Router 1. 1, 2, 3. router 3. 1, 2, 3. Okay, yeah, it's been driving me nuts. I mean, seriously, like... All right, so we need to boot up router 1, router 3, and router 6. And what we're going to do for source-specific multicast is, I believe we just create an access list. So let's say router 3, first of all, interface GI0, 1, 37. Oh, wait a second. Topology check. So that is this interface wants to join, but we only want to accept from GI0, 1, 146. Aha. So we actually need to boot up router 7. What we're going to do is we're going to make router 7 be the, he's not going to get picked for the team, only router 1, so he's going to have to sit out this game. And what should happen is we will join on this interface. But we're going to source here. Now, how is that going to work? Hey, LT, 2 streams back, I see you solving an issue about redistribution for EIGRP and OSPF day when studying. I see a table about default metric that is causing the issue. It became a flashcard about default seed metric for protocols redistribution. That flashcard helps a lot. Yes, it does. Yeah, so I believe I have a flashcard for that as well. I even had it in my written drill sheet. I had, you know, like what are all the redistribution metrics. In fact, I have that here. But of course, did I remember that when I was doing the lab? No. But in my notes, there is a redistribution chart, which I need to rename like ipv4 redistribution chart, because I really have not. All right, are we just gonna, we want to open, click, there we go. Excel, they recently announced Office 365 you now get from the Mac App Store, which I have. I've downloaded it, but kind of a disappointing. Office has never really been super awesome on the Mac, which I blame Microsoft for. But yeah, I have this, you know, when this is a destination protocol, and this is the source protocol, I have this chart like seed metric, infinity, but this is all IPv4. I need to do this for IPv6. Yeah, and those flashcards do help. Those little things, the flashcards help with those little things that you need to remember in a real lab, right? Or a real exam. So how is this going to work, folks? We're supposed to source multicast traffic from this interface. And we're going to join this interface. So the join will be sent here. It will, then we'll get a PIM join saying we have a receiver. So our router 6 is going to say, okay, I'm going to send. And it's going to get here and it's going to be rejected. INI loves these sneaky things. Like when you're trying to learn a protocol, they introduce sneakiness, which is fine on the mock labs. Don't give you sneakiness on a, all right, we're just going to configure it like as if because I'm detecting some evil sneakiness here. So what we're going to do is we're going to say interface GI0137, ipv6 IGMP join group, actually ff36:8, and we're going to have a source list. So ipv6 access list join permit ff. Yeah, we're gonna have to get help. This is something I could not find on Cisco's website, and I call myself looking somewhat thoroughly. So we're gonna have to get the parser to help us here. When we get desperate, we just use question mark. We use the question mark encyclopedia. You know what? I'm wondering what they're doing. I'm actually going to shut down that interface on router 7. Show ipv6 interface brief. Okay, our interfaces are up. On router 3, we're going to do ipv6 access list join permit. Let's see. So I guess this is the source. Problem is I don't have an example to follow, unfortunately. Let's go back to the interface. Also, Network Lessons did not have a lesson on IPv6 source-specific multicast. Oh, this is MLD. Oh, by the way, we have to do MLD. It's not SSMap. You would think it would be, but it's not. Interface GI0137 IPv6 MLD. Where do I specify the version? MLD. You got me. We're just gonna have to look at the lab answer. IPv6 MLD access group. Okay, that's what we could use, but it looks like it may already be running version 2. ff36:8. Okay, let's break down. Let's use our parser help here. Our desperate no documentation parser help. Okay, join group address. We already know that. And then, okay, we have exclude mode, include mode, source list. That's what I was looking for before. If it's just a single source, which it is here, we can say the sending R6s, we need his IPv6 address here, and it's this, right? 2001. Let's turn on paste. Let's see if the paste gods, copy paste gods are with us. They are. Whew. Okay. So now if we do show IPv6 MLD groups, yeah. Oh, there's another command. This I have a flashcard for this. Show IPv6 MLD. interface group source address. Yeah, that shows you. Okay. So let's try it. Ping ff36:8 gigabit Ethernet 0.1.1.46. Of course, it times out. Let's make sure PIM is actually running on that interface. It is. It's supposed to be. It's on. So these two commands that I typed is all it says to do. Actually, it's one command. That's all it says to do in the INE workbook. But I'll bet you there are things the workbook needs to tell me to do, but it's not. Let's see, show ipv6 arrays brief. So we get to troubleshoot a little bit. Really annoying though, I have to say. This should create a S, G entry, which it does. Cool, we've got our S, SSM group, L, T, and I. I think the unicast, I think our RPF check is going to fail though. Yeah. So we've got incoming show ipv6 RPF. Source address is that. Okay, I lost my clipboard buffer. I have my clipboard buffer here. I don't recall pasting anything else, but I guess it lost it. That's the source address. The group address is ff36:8. No route exists. How convenient. It did not tell me to do that in the workbook, but yet I guess it's assuming show, let's see. Yeah, it is running. GS0137, GS0113. But it's not running over here. Ugh. I'm telling you, man, this is so annoying. Sloppy Labs. Sloppy Labs. Let's see. Interface GI 0.1.1.46. 6 OSPF 1 area 0. Okay, now we got 3s. Now we just need 6s. 6 should be show ipv6 interface brief. We turned on OSPF on this interface. So why do we not have a neighbor yet? The line protocol is up. Global unicast addresses. Show run interface GI 0.1.1.46. ipv6 OSPF 1 area 0. So run interface J0, 1, 146. And it's not running here. How convenient. Struggle is real, folks. Struggle is real. So there you go. Many problems with IPv6 multicast are caused by RPF check failure. Usually some issue with unicast routing or interfaces that do not have PIM enabled. That should have PIM enabled, right? I know this because I have a flashcard on this. So now we should have routes. And we can see router 1, we can see router 6. We cannot see, we do not have routes to the, oh yeah, we do, 146. So now our RPF check should pass. And it does, and now this should work. And it doesn't. All right, let's troubleshoot. Well, guess what, folks? INE gives you a workbook to learn a protocol, but you can't get the candy until you do your troubleshooting first. So the troubleshooting is included for free. All right, let's do RPF check here. Show IPv6 RPF. And the source address will be this. Hey, it's still in the clipboard. The group address is 368. No route exists, right? Show IPv6 mroute. So we've got incoming interface. RPF neighbor, immediate outgoing interface list. Yes, that's all good. Router 1, show IPv6 mroute. Why is that? This is supposed to already be turned on, folks. There we go. Notice it lets you run the RPF check. Now it succeeds, even though multicast routing is not running. And we've got it finally. I love how it says no entries on here too. The IIL and the oil are here, and they are looking good. S and T. Let's get a quick PCAP and let's get out of here in this lab, man. This lab is messy. I sure hope the next one is written better than this. I say written. It actually looks written well in the workbook. It's just the initial configs. They are either they're correct here from INE. So, you know, they may not be at fault here. This could be an Eve issue. It could be a user issue. But somehow these configurations are like dirty. Even though I'm copying them in here, either they're dirty downloading from INE or they're dirty when they get pasted here and saved to the lab. I don't know. Or it's an even G functionality issue. I'm not sure which. I'm going to find out, though. I'm going to find out. All right, so this lab, we need to get a PCAP. And want to do that on router, let's say router 3. And then we'll go about our merry way here and try to get, hopefully get this something a little more productivity inducing. All right, let's try that again. Router 3. Second time's a charm. I've been seeing this with Eve Community Edition, that sometimes you have to do it a couple of times to actually get. All right, this is an MLD. We want to see. Oh, look at this. Interesting. So, never multicast address records, and these are all excludes. So by default, we don't want anything, right? And then at some point along the way, we're going to get an include here. So let's do IC and ipv6. We should anyway. I think I have to run an active ping maybe. Let's do that again. There are 5 records in this one. They're all excludes. Where's my include? Oh, here's our query. Okay. Query should give us some goodness here. Where does it say that I'm actually going to listen to? What is that, a generic query? Yeah, this is a generic query because the multicast address is unspecified. Wait, is this? Which router is this? Yeah, we might not even be looking at the right router here. I told it to capture router 3. So we want the source to be what are his IPs? Show ipv6 interface brief. FFFE03:1. Yeah. So where is he saying, hey, I want traffic for, there it is, include. Found it. And this is a query. What if we try to send it over here? Yeah, ping. This should not go through, right? This should be rejected. FF368. FF368 gigabit Ethernet 0137. Yep, rejected. Show ipv6 en route. Probably already enabled, but it's not. Okay, notice outgoing interface is null because it would have probably sent the packet, but MLD would have sent an exclude, which we should see here actually. This is when it came up. Oh, he probably heard, router 7 got the, notice the include though is going to say from this source. So router 7 is going to know right away, I can't even send you that traffic. I can't add this to the oil because it's not the right source. Nice. All right, that's our lab. Good stuff. We got to, we got to do a little troubleshooting, either thanks to INE or even G. I don't know yet. I'm going to find out. IPv6, PIM, ML, PIM, SSM. We'll just call it that. Here's our, we should have saved these two. Here's our join and prunes. Because it's running PIM too, right? Upstream neighbor, group, join. Yeah, here's our join. We need this too. Let's mark that. And it's going to send a prune. Not sure what that looks like. Router 1. That's probably a timeout prune, I'm assuming. But we start sending again later. Join S flag. Nice. Okay, let's actually save this. Nice. Okay, and we're going to copy these PCAPs, our new specimens, to this folder. Okay, they are there. I was starting to worry, like I'm not seeing all my PCAPs. So let's upload those to the GitHub. Let's see if it's tracking them. It's not. I'm not sure why. And they're up there. In the repo. All right. That is going to wrap it up, folks. Good labs. Started this morning. Don't have any meat chunks. Haven't done really anything social media today. But it's good to hang out with you folks. It is Wednesday night. I hope everyone has a great Valentine's Day tomorrow. I will probably be here labbing. So, if you want to hang out, come hang out. And we'll, do another lab. What are the upcoming labs? Let's take a look. Do we have any more multicast? I actually think that is going to wrap it up. I kind of wanted more. But hey, tunneling. That's going to be cool. Actually, I'm looking forward to this. I did do a few little tunneling labs for network lessons when studying for the written. I have not really done any out of this workbook. So there are 3 here. ipv6 tunneling, I have a feeling it's going to be GRE. Then we have automatic 6 to 4 and then isotap. And then this weekend, I'm going to say that by this weekend, we will probably be starting the dreaded QoS. So here we go. Let's do it. Thanks for hanging out tonight, folks. Good to see you. We shall see you back here tomorrow night on the Land Tamer stream. You can follow me on Twitter, Instagram, YouTube, and of course here on Twitch. And feel free to, if you got a Twitch Prime sub, free Twitch Prime sub that you haven't renewed, sitting out there, feel free to just give us a sub as well. Thanks so much for stopping by. We shall see you folks again tomorrow night back here on the stream. Have a good night.